So I'm going to explain this Leetcode program, 75 short colors. This medium difficulty, so I set 30 minutes as my like the timer. Uh, so here's what I did in the first 10 minutes. Like checking, reading the description and writing down the like important information like this. Nouns consisting of like these numbers and stuff, and the constraints as well is important. And I came up with these three kind of solutions. One is temporary. Using temporary, we can copy it, like elements to the temporary, and placing the like the values from smaller value, like from zero. Like in the first traversal, I put all zero, and the second one I can put all ones, and this and so on. Yeah. Then copy it back to num1. The second one swap, like the like sorting algorithm, starting from like the first index and swapping everything, like like starting from the first and compare it with the next one, the second next one, and everything, and swap it whenever I find the smaller value again and again for every like index, and you can make it with like uh, nested for loop, but it will take a big O of n square because it's nested, so it's not as efficient as the other solutions. The third one's like the most simple and also like efficient in time and space. It just count. So here's the original array nums. Um, you just traverse one by one and count like num 0 1 2, a number of zeros, ones, twos, and store it whenever like as it moves and finds the value of at this index, like index one by one. Then we just create again traverse, and depending on these values, we replace the override the number with like zeros, ones, twos, depending on the position. And this I'm going to show my code. Hold on. And here's what I coded. Like, and everything took me like 60 minutes to like get my solution passed. So 60 minutes. Yeah. And I run I code few times and got nah, like my solution was incorrect because I didn't put my initial value like in here, and that make gave them like initial value of random integers. Um, in this traversal, nums like number of these variable got it wrong, so um, like this loop didn't like work properly, like or as intended. So yeah, and this one of course, efficiency is big O of n, like in time, it it just take constant space, like space. So this is as good as like the solution that uses this algorithm, like as like many people introduce this solution in the comment, but it's just simply this counting the numbers as good as uh, the solutions introduced. But I'm going to explain this algorithm uh, here. So like I've already shot the video like before, but it's not really structured well. So I'm going to re-film a video and post it. So I just remove everything and oh shit. So nah, I'm going to draw it here. So like let's say you have a initial like original array consisting of these five like indices. Let's say 2 1 0 2 1 let me nah, 0. And in this algorithm we use three pointers named low, mid, starting from the first index, and the high, uh, uh, and positioned in the last index. Uh, and conventionally, these pointers are named like this: low, mid, high. But for you to easily understand, rename it with. I mean, these name are like good when you're rearranging the array of integer, because like between these elements there's like higher, like there's always higher and lower or equal, but this algorithm could be applied to any data, like array of like any like user defined data. So I positioned it, I name it first for first boundary boundary. um this was initially low, and the second pointer, which was mid, I name it as current pointer, uh, current. And the last pointer, which is supposed to be named high, as second boundary. Mm, so like as the name this current pointer suggests, we're going to mainly move this pointer to the right, one by one, um, swapping the element depending on the like the content we find at the index where the pointer points. Um, so first step, let's say we focus on this pointer and where the pointer points at. The pointer is pointing at the first index whose value is 2. So like in the end of this operation we want the the index to be like sorted 1 1 2 2, uh, and we want each of the like this pointer to be located at uh, mm, located at here first, and this is the current and second. because the first this pointer is kind of works as a boundary between uh, the first sector and the second sector. We like in this case like the boundary between zeros and ones, and we want this pointer to work as like a boundary between the second sector like here and the third sector. The current point like current is just like what we move around, and at the end of like we can end this operation when this current pointer current reaches uh, the net like we uh, like go over the second point. I mean, whenever this current pointer goes like inside like go beyond this boundary, and like inside here inside these boundaries we can it's guaranteed like the whatever content here is like appropriately positioned. uh, so we starting from here, like first boundary is not working, like it does nothing for now because the boundary here is like here, uh, and we don't have anything in like before the boundary, and like we can say the same thing as this second boundary is now here. So we want all like all zeros and twos to be positioned um, like before these first boundaries and after this boundary. We want it to be like here, like after the boundary, um, like before the boundary, like outside, and inside this boundary we want it's like a second sector. We want all ones in between. So we start from here. So this initial state, the first boundary, and the current is here. So like we find these two, and what we want is we want these two to be put like, like beyond the boundary. So what we do is we swap these two with the one where the like this pointer is pointing. We swap it, and what we do is we move the boundary to the next. Then we can say whatever the data after this boundary is already positioned. So like 1, 2, 3, 4, 5, 6. The boundary is now here, and it's already sorted. I mean position, and we move the pointer to like one to like by one, move back, yeah, move back by one, and the boundary is pointing here. Um, so we swapped. Oh shit. So 0, 1, 0, 2, 1, and second, and the current we don't move uh, the first one and current. Uh, we don't move this current pointer because we just swap this data, and we haven't analyzed this content yet. If we move this current forward, we we will never analyze this uh, element. And if it's zero, it's fine, it's positioned well. But suppose it's one and swap this two here is swapped with one, and we move the pointer to the next element, then the one will never be moved, which is not what we want. So we do the same we do analyze this like the data at index 0 again. um, so this is what we do when we find data to be stored in third sector. First we swap, and we move the pointer. This is the two things we need to do. um, Next, I'll explain when we find zero or data to be stored in the first sector. So we find zero, and it's kind of hard to imagine why we need to swap uh, data at which this first pointer and current pointers are pointing, because they are now at the same position. But mm, so I'm going to explain later when the current pointer pointing to the third index. I mean the index of 2. So when we find, then after this swap, what we do is we move for these two pointers to the next position by one. So now this first and current pointer pointing to the index 1. uh, um, okay, so because this first is kind of works as a boundary. So uh, like what I explained in the step 1, we do the same. So now we didn't have any boundary yet at this point, but now we can say this in this element, or whatever like data before this boundary is appropriately positioned. So we can move the boundary to the next position, and the current pointer, yeah, we move it, and now we find one. And it's easy. What I do is just move the current pointer to the next. That's it. Because what we want is whenever we find 0 or 2, we just swap it, then move the boundary. That's it. That's the everything we need, in this operation or algorithm. So we move it, and we find 0 again. We found 0 again, and what I what I explained, we need to swap it first, because it was kind of hard to like understand why we need to swap the content in this step. But if you look at here, it's not really positioned well, because the boundary is here. Boundary is here, and we have unsorted content after this boundary. So what we want is we want to put this zero or to like to the one, like the right after the boundary. This is boundary, this is boundary, and we want to put zero right after this here. Then we want to move the boundary. So what I do is we swap we swap it with this content at which this first pointer points. Then we move the boundary. So now what the array looks like is 1 2 5 0 0. We swapped it, so 1 2 1 2. Then the boundary is here. First boundary is here, and second boundary is here. Second, and the current pointer is here. So we found two again. So like what we did in the last operation, we found two instead of zero. So what we do is we want this to be placed next to this boundary, before the boundary, and we want to move the boundary. So yeah, do the same. So like 0 0 1 1 2 2. Now, and we move the boundary to the left again. Uh, okay. So and here, because here, like the index of 4, initially, like having the value of 1, uh, we don't have to like move it. But suppose let's say we had 0 instead of 1. We need like to like operate again. So in this state, this array could be unsorted. So we like we need to continue the operation until the current pointer like go beyond the boundary. And the once the current pointer go inside the boundary, like we don't have to traverse the array anymore, because um, this sector is already sorted. So we we found like what I explained. Whenever we found 1, we just moved this current pointer to the next. Then then the current pointer is already go beyond this second boundary pointer. So in the code, what we can code is, inside the for loop, we move it, and we have if condition, um, depending on the depending on the value, like the nums of the current pointer, the the current pointer is 0 or 1 or 2, we do the operation. So let's say if it's 0, we swap, then we move the boundary. If it's 1, no swap, we move the current pointer. Else, if the pointers are like, no, the value is 2, else is 2, and we swap first, then we move the second boundary, like second. Then we do it. Um, we we repeat this operation until uh the current pointers is go like beyond this second. uh no no no, like while we while this we continue doing this operation, then once it's done, it's already sorted. um this algorithm only needs to traverse the array once, while this solution needs to traverse the array twice. One, like the first time to count the number of like each element, and second time we need to like position it. But here only need like once, like kind replacing the elements real time. Yeah, that's basically it. So this is about Dutch national flag algorithm. So I'm going to keep doing this recording. I'm kind of try every day, like until like 4 months, like September, I guess. So, all right, see you.